So hey, today we're doing 2.8, our last section in here, proving statements about angles. We'll finish off our super fat stack of notes, okay? Then on Thursday, we're taking a quiz over 2.7 and 2.8, proving statements about segments when we just discussed, and then proving statements about angles when we're about to discuss, okay? Then we're going to, for the remainder of that class, we're going to start reviewing chapter 2, okay? We're looking at a test next Wednesday, my dudes, okay? So on Monday, we'll be continuing to review chapter 2, okay? Finish that off. On Wednesday, and we'll discuss our quiz as well. On Wednesday, we'll be taking that test, okay? If you're going to be gone that Wednesday, and you know you're going to be gone that Wednesday, let's take this on Tuesday, okay? So schedule with me a time to take it on Tuesday there, okay? So that way you still get your review, you still get to discuss your quiz, that kind of stuff, okay? So schedule a time with me to work that out, please, and thank you. Okay? So let's flip over section 2.8 here. Oh, yes.
Wait, no, don't actually take it. Just give us all.
Okay, probably.
Yeah, I
Didn't do well. Grammar's hard.
I kind of lost.
I bet.
Maybe you just didn't watch that video.
Yeah, maybe if you watch the video.
Taylor, you lied.
I know.
But you don't let me forget I put this here, okay?
Let me forget this.
I think you're just overreacting way.
I called Betsy fast earlier, so
Like,
we got that connection.
I don't bite or whatever.
Why y'all so weird? Alright,
No.
we're going to start with this angle proof reference, okay? Angle proof reference, okay? I should put a page number on these.
No, you shouldn't.
You should just give us one.
We're on page 31.
You should just cover. How do you know what page?
Yeah, you should stop
I
teaching
wrote
geometry.
Oh, nice.
Who is the creator of geometry? Like, who is the founder of geometry?
So like actually this geometry we go over is called Euclidean geometry because it was done by the mathematician Euclid. But there's lots of different kinds of geometries that are non-Euclidean geometries as well.
Okay, well, somebody who created geometry
Euclid.
should.
So, angle proof reference! Okay, so we have our properties of equality,
Wait, where?
we have our properties of congruence, okay? We have Maggie taking out her headphone, okay? We have our definitions here, okay? We have definition of congruence, same thing like we did for segments. If the measures are equal, segments or the angles are congruent. Let me try it again. If the measures are equal, then the actual angles are congruent. And definition of angle bisector. An angle bisector divides an angle into two equal parts. We know that. We know that, right? Know that? Angle bisector bisect two sections. Okay.
Sure.
Definition of complementary angles means they add up to 90, okay? So if they're complementary, they add up to 90. Their sum is 90. Definition of supplementary. Supplementary means they add up to 180, okay? And it goes both directions, okay, for these definitions. Hence why the double arrow, it's biconditional. Definition of perpendicular. Perpendicular lines form right angles. You have right angles, you have perpendicular lines. Definition of a right angle. A right angle is 90 degrees. If you have 90 degrees, then it's a right angle, okay, by definition. Okay? This is a reference page for you to look back to, okay? Postulates, angle addition postulate. Similar to the segment addition postulate. Two parts of the angle add up to be the whole angle. Okay, we covered that. Then we have these different theorems. We talked about these. Vertical angles theorem. If two angles are vertical angles, then they're congruent. They're congruent, they're vertical angles. Okay? Vertical angles are congruent. Okay? If you need a little picture of a vertical angle again, okay, those were the X. Okay? So these two would be vertical angles. Okay? Complement theorem. If two angles form a right angle, then they're complementary. It's called a complement theorem. If two angles form a right angle, then they're automatically complementary. Okay? Supplement theorem. If two angles form a linear pair, then they're supplementary. Congruent complements theorem. We're saying if angle A is complementary to angle B and angle C is complementary to both, then excuse me, let me try that again. If angle A is complementary to angle B and angle C is also complementary to angle B, angle A and C have to be congruent. Okay, give me a measure for angle A, Kayla. Something less than 90. Cool. What plus 60 would make it 90? 30. So B is 30, okay? So now, since A is complementary to B, B is still 30 degrees, so what would C have to be in order to be complementary with angle B? 60. So, angle A and angle B, they're congruent, aren't they? Yeah, because they're measured to be equal. So if two angles are complementary to the same third angle, they have to be congruent. We call this the congruent complements theorem. Complements, because we had two different sets of complements going on, A and B, C and B. Congruent, because two angles end up being congruent. Same thing with congruent supplements theorem. Two sets of supplements. Angle A is supplementary to angle B. Angle C is supplementary to angle B. So, congruent. Angle A is congruent to angle C. Same idea there. Does that make sense? Okay, awesome. Same idea as this one. We just change up the numbers. Okay? So once again, complements, supplements, multiple things being supplementary, multiple things being complementary. And congruent, okay? Two things being congruent with that. Okay, this is a reference we can use later. Okay? We're gonna practice this by going through some of these definitions, theorems. Yeah. Tasha, thank you. I was thinking the last word, but I couldn't get it. So thank you. I appreciate that. I was struggling with it. Okay. So number one, if angle A is the right angle, then measure of angle A is 90 degrees. Great. No, complementary is how many angles? Two. It has to be two angles to be complementary to add up to 90. Okay. Another angle theorem. Go back, Kevin.
Definition of complementary, or
Definition of complementary means that the sum is 90. So sum means you're adding, right? Do we see any addition going on here? No. Okay, Alyssa. Awesome. Definition of a right angle. Definition of a right angle. That's just saying, hey, it's a right angle, 90 degrees. Okay? You can go back right to the previous page notes where we just went over. Okay? And it says right there in definitions. Okay? We can use this as a way to help us. Okay? Hey, we have through 12 on here. We have through 12 on here. Okay? And these will all come straight from our angle proofs reference page. Okay? Evan and Simone, you guys are doing 2. James, Michael, Stevens, and Jocelyn, you're doing 3. Okay? Kayla and Kevin, excuse me, Kayla and Kevin are doing 4. Okay? Graydon and Rachel are doing 5. Okay? Justin and Betsy are doing 6. Okay? Let's see.
so you're doing 4.
Yes. Taylor, Sarah, and Maggie are doing, what are you on, 7? Did you guys do 7 or 6? Okay, you guys are on 7. Okay? Rowan and Alyssa are on 8. Okay? Riley and Ava are on 9. Okay? And then Amber and Carly are on 10. What did I draw on the left side? Here, maybe this will help. Give a little X. Middle angles are all to each other. Share the X. Once you're done, discuss with your partner, right?
What do you mean? I can't get my you get the question I wasn't ready. Like, it's because you don't want to do it better than me. Like, well, that's what it is.
Okay. Let's start talking about these. Okay. So on number 2 here, Evan and Simone, what did you guys get? Very good. The congruent supplements theorem. Okay. And the reason here is you have 2 different sets of supplements x supplementary y, angle x is also supplementary to angle z. So you have two things being congruent. Angle y is congruent to angle z. So our giveaways on some of these, I'm trying to teach you guys giveaways to remember these, okay? Two sets of supplements, and then something being congruent. Congruent supplements theorem. Okay, number 3, Jocelyn, James, Michael, Stevens, what did you guys get? Vertical angles theorem, very good. Okay, these two are by definition vertical angles. They are opposite each other. They share this vertex, okay? Their sides make those x or the straight lines, okay? So they're congruent. So vertical angles theorem. Okay? You don't if you didn't do that one right, you should be filling that in. I see most of us are, okay? Kevin and Kayla, what did you guys get for 4?
Complement theorem.
Okay, that is complement theorem, okay? If two things add up to 90, then they're complementary. Okay, what would be our complements theorem? Very good, okay? Okay, on 5, what did you guys get, Rachel and Graydon? Okay, definition of complementary angles. Actually, excuse me, I would switch those around. I misspoke, guys. I'm so sorry. 4 and 5 would be switched around, okay? So 5 would be our complements theorem, and 4 would be our definition of complementary angles. And let me explain why that would be. So if we look back at the previous page for angle proofs reference, and we compare them to this one, if we look up at definition of complementary angles, it says if they're complementary, their sum is 90, or vice versa. Here, sum is 90, they're complementary. So that's a word for word really match there on definition of complementary angles. Whereas if we look down at complements theorem, which is what we get on 5, we see if two angles form a right angle, they're complementary. Okay, that's what we have here. They form a right angle, so they're complementary. That's my bad, guys. Sorry about that. The first one's definition of complementary angles. This one is complements theorem. And hey, once again with our definition, we're going from words or from math to words or vice versa. Okay, once again with the definition, we're going math to words or vice versa. Okay. Number 6, what did you guys get, Justin and Betsy?
Supplement theorem.
Okay. I disagree. Okay, I disagree. Okay. On 6, we have these two lines, and we're saying, okay, if L is perpendicular to M, then angle 1's a right angle. Okay. Which one of these do we see that talks about things being perpendicular? Anybody can help? Anybody can help? What do we see that talks about things being perpendicular? Okay.
Definition of perpendicular.
Definition of perpendicular. Perpendicular lines form right angles. Are we seeing here perpendicular lines forming a right angle? Yeah, so that'll be definition of perpendicular. That's why we're practicing, right? Okay. And on 7, what did you 3 ladies get?
Definition of supplementary angles.
I would agree, that is definition of being supplementary, okay? Once again, we go from words to math. Anytime we go words to math or vice versa, probably a pretty big hint we're doing some sort of definition, okay? So W and X are supplementary, well, they have to add up to 180. That's our definition, okay? Number 8, Rowan and Alyssa, what you guys get? I would agree, congruent complements theorem, okay? We have multiple things being complementary, so multiple complements, and then leading to angles being congruent. That would be our congruent complements theorem. Okay, number 9, Riley and Abel, what did you girls get?
Supplementary theorem.
Yep, that would be our supplement theorem, right? If two angles form a linear pair, then they're supplementary. It kind of goes along with our complements theorem we had earlier. They form a right angle, complementary, they're a linear pair, they're supplementary. Okay. 10, Amber and Carly, what did you guys get?
Definition of complementary.
Awesome. Definition of complementary angles. I agree, okay? And once again, we're going from some words into some math. Anytime you do that, or vice versa, big hint is the definition. Okay? 11, okay? Redemption shot here. Justin and Betsy, what did you guys get?
Angle of addition posture.
I would agree that would be our angle addition posture. We're taking two smaller angles, adding together to get the big angle. Part plus part equals the whole. The two parts equal the whole thing. Done together. Okay? And then 12, we haven't done this one yet, but what do you guys think? Okay, we go from two angles having their measures equal to now the two angles are congruent. Definition of congruence, right? We've done that one quite a bit between our sections. Okay, hopefully this is a good way for us to get a little more used to using these, okay? And we can keep going back to this angle proofs reference that we started with, and then this page we just did now to practice as we go through our proofs to help us out, okay? We'll continue to look at that. Hey, if we put the page here, we see another one of these angle proofs guides, right? We see another one of these guides here, okay? Now I think I actually forgot to include these yet onto the next slides. I think I forgot to include those. So sorry about that, okay? See. Yeah. Do you want me to include this real quick and take like 2 seconds, or want me to just keep going?
Keep going.
Include it,
No,
include it.
Adam?
Keep going.
1 1,000, 2 1,000. What?
Even I don't make that joke. How does that make you feel? I don't even make that joke.
You do make that joke, like once a day at least.
No, I don't.
You laugh on us.
Also, that is true.
Jonathan, you did this to yourself, Jonathan.
Make it really long.
Long boy.
Yes.
Quiet, Jonathan.
Do it. Stretch it.
Hey. Stop bullying him.
You're mean.
I told him I was gonna do it.
And you moved on the last one.
Oh my goodness. Hey, good boy.
You need a word thing.
Oof, that one's gonna be hard.
No. Put it away.
Just make it really long. Do it.
I like pimples.
Yes.
Yes.
Alright.
And a box of it. No way.
Yeah, I'm really happy about that.
That took way longer than you think, Mr. Possible.
Oh, you see that? Explode out, okay? Hey, so we're back at number 1 now. We have these 6 proofs. We're gonna try and get through, okay? We're gonna get right, okay? We might not do all 6. We're gonna do all 9, okay? Okay. Anyway, so
Oh my goodness, almost done this packet.
yeah,
Wait, there's so many of these.
yeah.
No.
Okay. So we're giving the left side. We're putting in reasons now, okay? So angle PQR is a right angle. Who wants to call dibs on doing this one?
Not me.
Okay, Riley.
Given.
Given.
I disagree.
Oh, what do you think it is?
It's gotta be definition of
I think you're right. It is given, okay? Okay. So we go from it being a right angle to the measure of angle PQR is equal to 90 degrees. What do you think? Tell us we can go from the word to some math.
Definition of complementary.
Definition not a complementary, but definition of a
Right angle.
Okay,
Right
that was-
angle.
That's kind of the same thing.
Okay, a lot of these times when we see these definitions, it'll include the words with them. A lot of times when we see the definition, it will see the words with them.
I don't have that.
What?
I don't have those little word
I know. You have it on the previous page.
Yeah, you have on the
He just put those on.
That's what
We
I literally
watched
just did.
him put those on there.
things. I didn't
Well,
know
some
that.
of you were just talking instead.
I was. That's
Yeah,
fine.
but, Then we go from step 3. How do we say measure of angle PQS plus measure of angle SQR is equal to the whole thing PQR?
That's an addition.
Angle addition postulate. We're seeing a lot of overlap between these and like the segment ones.
I'm definitely about to fail.
Nope. I already knew about that one. Mr. Cousins.
What is it?
You've met so many people.
I have.
He's
Okay.
basically better.
4. Measure of angle PQS plus measure of angle SQR is equal to 90 degrees. I would agree. That is our. Oh, excuse me, I'm not quite. Sorry. Here's the thing. Okay? We have something equaling measure of PQR. We have something equal in measure of PQR here.
Let's translate.
So they're equaling to each other.
Yeah.
Transitive. Okay? Now let's talk about this, okay? So PQR, those overlap. We see 90 and we see 90. Okay? And we see PQS and SQR, PQS and SQR. So we have both the purple and the light blue are equal to the red. So they're equal to each other. Okay? Rachel.
What is transitive?
Transitive property saying that if A is equal to B and B is equal to C, then A is then equal to C. So we're saying if these two things, A and C, are both equal to the same third thing, they have to be equal to each other. If I run the same pace as Jocelyn and I run the same pace as Betsy, then Betsy and Jocelyn run the same pace.
I thought that was isn't there like 6 different ways to do that?
Oh, I got it. Segment addition is like this part plus this part equals the whole thing.
That's the
What is the one that's
Addition.
similar to
Substitution.
Mr. Costle, can you catch?
Okay. So the times you would use substitution is if you were told specifically like, actually on this one you could use substitution because we're told that measure of angle PQR is equal to 90. So you can just substitute this straight in for those two. That's the only thing that swaps. So there you could use substitution. Okay. Okay. Alyssa.
Okay, so which one out of like all the numbers that you just like
Yeah.
highlighted,
Right.
which one's A, B, and C?
Okay. So they really could vary. Okay. So we could call if we wanted. We could say, I guess for this to work the way we want to work perfectly, we call this one like maybe B, this one A, this one would be C then, which would make this one A again. So now we have A and C, for example. Does that make that any clearer? Okay, Sarah.
Is the transitive property like slow?
Yeah.
Yeah. Just think it like that.
Okay. So now, big hint, we go from math into a definition, and it includes words complementary. We go from math into words, which means we're probably doing a definition, and we see the word complementary in there, so we're probably doing definition of complementary angles.
Alright, so last one. Can we do that? Wait,
I have a
wait,
question.
genuine question. When are we going to use this in life?
Okay? This is teaching you to form logical arguments without skipping steps. So that way when you go and argue with people in real life, you're going through a logical argument, skipping steps, and you're not just jumping from something else to something random, and you're not saying, well, I can prove that the sky is blue, and it's because the floor in here is dry. Well, those aren't related at all. Like, they're both facts, but they're not related. Okay? So that way we're not just saying, like, oh, well, like, these angles are complementary because the segments are congruent. That doesn't make any sense.
I really don't think
So why do we have to learn that?
Yeah,
okay. It's made me a better argument.
Argument. You just said argument.
Yeah, arguer.
Argument.
Prove me wrong.
I will.
Using a logical argument. Riley.
So on the test or quiz or whatever,
Yes.
are you gonna put the words?
Probably not.
You really
Okay, there's gonna be a lot of these where they have either the statements or the reasons or some of
I
both.
don't even remember what some of these things are.
Okay. If I remember correctly, I don't think there's any on the test. Okay, where they're
That's
entirely
insane, Mr. Costle.
for the segments or angles.
Did your thing get bigger?
Yeah, actually, I sprayed some water on it and it grew. I put it in the right sunlight.
Can you catch?
Okay, no. I just told you I could. Let's go to the next one. Okay.
Can you catch these hands?
No, you don't want to catch these. Okay. Number 2. Okay. It is the first step's gonna be given always.
What if I wrote proof?
Definitely.
Then you're wrong. Okay. Hold up. Okay.
Something about being.
So we're told angle 2 is equal to angle 3. I'm gonna go ahead and mark that. Okay. We can also see we have another given here, don't we?
Yes.
Or we're gonna have it later.
Sure.
Okay. If we want to, we can fill it in now, or we can go and keep going.
Where was it?
Number 3.
Okay.
No, it's not. Yes, it is. It's the same thing, Kristen. Stop hurting yourself.
Okay. How do we go from step 1 to step 2? What happens? We go from them being congruent to their measure equal, so that's the
Definition of congruence.
definition of congruence. Let's see, have fun back here. She's having a good old time. I don't know what she's doing, but she's enjoying it.
Oh, that, yeah, I was.
How did you forget that?
Okay. So then we take another a curve a little, and we say, okay, angle 1 and angle 2 form a linear pair given. So off of that, if they form a linear pair, then these are supplementary. What tells us that?
Theorem of supplement theorem.
Supplement theorem. You might be confused, is this a definition supplementary or is it supplement theorem, okay? Definition, we typically go from words to math or math to words. Are we doing that here?
This is words to words.
No. We're going words to words. So it's probably just our supplement theorem then. It's probably not a definition, okay? Remember, definition, usually words to math or math to words, okay? So now from 4 to 5, you're going from them being supplementary to now math, they add up to 180.
Def of supplement.
So that's going to be our definition of supplementary angles. Because we have supplementary in the words.
And then I know this one.
Oh, hold up. Calm down. Okay?
Oh.
So, now we have measure of angle 1 plus measure of angle 2 equals 180, and we go to measure of angle 1, measure of angle 3 equals 180. What changed between 5 and 6? 2 became 3. Were we told they equal earlier?
Yeah.
So we can substitute them out. And I'd be okay if you just wrote subs even. You don't even have to write the property for subs. I'm telling you that now, okay?
Can you please put a word?
Why is it just not a sub?
Because there's
Okay.
subtraction.
So,
That's
we can say the measure of angle 2 was equal to the measure of angle 3, which is what we substituted, right? Okay? And then we're only left with one thing, but we don't even want to just get caught in the being left with one thing category. Okay? We went from math to words, and the words involve supplementary. So what probably did that?
Definition of supplementary.
Definition of supplementary angles. Remember, math to words or words to math, probably a definition. Okay? Now we work through this logical argument. Okay? Question on that one. Right? Okay? I want you guys to try let's go with I want you guys to try number 5 on your own.
Oh.
I
don't like
number
you.
5 on your own. Yes.
Okay, so you said it's supposed to help us with like logical things. Are we supposed to use this process in our head, or is it going to make that more logical that
I mean, it takes practice to get there. You know, like over time, you'll have to be able to just kind of do it. But at first, you're probably gonna put it away. Put it away. Oh, well, we're just doing one problem. Thank you. But over time, you're gonna be able to get there. But at first, you're probably gonna continue to like think through. Okay, so like if I can connect this to this, am I missing any points here? Is somebody gonna get lost? Is somebody gonna remember that I'm doing this? It's kind of like giving like insanely detailed instructions to somebody. Like you're telling me to put together like to make like a peanut butter and jelly sandwich. Okay. You say like, okay, pick up the bread. Okay, pick up the bread. Okay. And you say, you know, like put your knife in. And you say like put the peanut butter on the bread. Now let's just say I took the dark peanut butter and put it on the bread. Did I do what you wanted? But did I do what you
Yes.
Yeah. Okay. So we're going piece by piece, making sure we don't miss any points. Make sure people can follow through it. So if you want to win arguments, you have to make sure people are following you. Because if you lose them partway through, they're not going to come to your side. That make sense?
Yeah.
So we're going through piece by piece and not missing steps. Does that make any more sense at all?
Yes.
Okay. Yes. Let's look at the picture.
Anyway,
RSU.
you know what I'm talking about?
RSD. RSD.
Yeah.
Yeah.
This is a part
I
of.
forgot.
What are you adding? Are we adding segments?
Oh, yeah. I like.
These are segments. No, what are they?
What?
Angles. So, if you need help,
If I
I'm
ever
gonna go back and look through. Hey, remember
No,
how
now I can. It was with
What's the GPA for Cambridge?
Did I play it on my Xbox? I play it on my Xbox with this kid. And every time we argue, he will literally make no sense. And then you argue about something that makes no sense. And then to make himself like win the argument or whatever. I was like, that makes no sense. He's like, what? You're making no sense. I was like, no. I'd be like, shut up, Scoot. I'd be like, no. But even, and it was different. Weird. It's hard to explain because I'm too stupid to remember stuff. I mean, I know how it went, but like, I don't know how I remember it to say it. To explain it.
What did you use?
What?
Does it look any different?
I just saw it on like
What?
already overlaid.
Ben loves you. I'm just using
Did you already
over text because we're in the same car and you're so good. But he said backwards, so he said, oh, it's shut. And he's like, I'm saying no, no. So randomly, looked like we'd be like, oh, let's do shut.
You pointed it out.
Okay. Let's see. Everything else.
I don't know.
Right when I did it.
Actually, I was even worse.
Oh, yeah, it is.
Oh, well.
When I actually did it.
Yeah, before it's an album.
It's not my son.
Yeah, like usually about LSU or weight and
I might be getting, if our house is so old that we don't have anything for number 5, why we live there.
So what's our break? What's your switch degree? What's your switch degree? To 6, what's the one we have used? That's good. So RSP is equal to USD. We told you. RSP, USD, both equal to USD, RSU. Okay, we're gonna go and talk about this one up here. Okay, we're gonna talk about this one up here. I was rolling with my pen that I didn't use. Okay. Okay, so what's our first reason, Rachel? Right, Gavin. Okay. How do we go from being congruent to being the measures are equal, Taylor? Very good definition of congruence. Okay. Once again, big hint, guys. Big hint. Typically, when you start out with congruence, we're gonna move it to being equal. Okay. A lot of times when we start out with congruence, we're gonna move it to being equal. Okay. Step 3. What's our step 3? Anyone want to help me out there? Sarah?
angle addition process.
Yeah, very good. Angle addition postulate. You might be looking at like previous, like 1 and 2 things. We don't understand how it gets there. Look at the picture though. RSU, USB, add up the whole thing. RSV. Those 2 parts make a whole there. Okay. Can I get any help on number 4? Okay. Let's go ahead, Riley.
Angle addition.
Yeah, it's our angle addition postulate once again. Okay. Angle addition postulate. Okay. Just like post alone. Okay.
I like how you do scribbles and then lines as well.
Right.
Doesn't match out.
BST plus USB make up UST. Okay. Now what changes between steps 4 and steps 5? Something subtle changes. James, like to see this?
Substitution.
It is substitution, okay? And what did we substitute there? Yeah, measure of angle VST was equal to the measure of angle RSU. What step were we? What did that come from that we knew that information? Okay. Steps 2 told us that information, but then we used 3 to get to 4, right? We used steps 2 and 3 to get to that, or 2 and 4 to get to that one. Yes. now we have measure of angle RSB is equal to measure of angle UST. Well, angle RSB and angle UST, were they both equal to the same third thing somewhere? Yeah, on steps 3 and 5, they're both equal to the measure of angle RSU plus the measure of angle USV. So if they're both equal to the same third thing, they're equal to each other. So what's that property tell us? What? That's our transitive property. And our transitive property tells us that. I worded that wrong, sorry about that. What property tells us that is what I meant to say. And that'd be our transitive property. So now we go from the measures being equal to them being congruent. That's a big hint for our definition of congruence. Okay. Okay. What we're gonna do here, guys, is we're gonna end up flipping the page over. Flipping our page over. Okay. And I want us to look at. Let's look at number 9. Okay. Let's look at number 9 here. Okay. So 9 is one of these where we don't have anywhere the whole thing's blank. That's kind of nice. We have some words that are different parts, and we don't have a word bank. Okay. On number 9 here, we're gonna go through this together. Okay. We're gonna go through this together. Okay. There's already at least one you should know how to do, right?
Yeah.
Which one should we all know how to do? First reason is given. I hope we'd all know that. Okay. Okay. So we're told that line AB is parallel to line BC. Okay? And then we're told that angle ABC is a right angle. How can we draw that? If we go back to our angle reference, in a couple pages, what tells us we go from lines being perpendicular to there being a right angle? We go back to our angle proofs reference page. What tells us? Definition of perpendicular. So even though we didn't go words to math this time, okay, that's still a definition of perpendicular. Sometimes it's not words math, but words math is a big hint definition. Okay? So we have on reason 3, we have definition of right angle. So ABC is a right angle. So what do we know the measure of angle ABC must be equal to? 90. Okay? So now with this definition, we do go words to math. Okay? We don't always, we didn't from 1 to 2 with the definition, but we did from 2 to 3 with the definition. Okay? More often than not, definition will be words to math or vice versa. Okay? And just think about, oh, what's it mean to be a right angle? Oh, it's 90 degrees. We know that. Okay? So now we have measure of angle 1 plus measure of angle 3 is the measure of angle ABC. Measure of angle 1, measure of angle 3 out of the whole thing, measure of angle ABC. That is our angle addition postulate. It might look a little bit weird to us, because normally we have like measure of angle like ABD and BBC, but it's the same name. It's a different name for the same angle. We talked about that in chapter 1, how we can name angles, either by the number or by those points. Okay, so now we're told in step 5 that measure of angle 1 and measure of angle 3, now they equal 90 degrees. Well, how can we get there if we were just told that they're equal to measure of angle ABC? Substitution or transit. I'd be okay with either. Okay, I'd be okay with us either calling it transitive or substitution. Okay, either one you want, perfectly fine by me there, because either one's applicable. There's a lot of times where they overlap, and there's a few times where they don't. Okay, if it's substitution, we're substituting that the measure of angle ABC is equal to 90 degrees. Okay. Hey, big hint here. What's our big hint for step 6? We have a definition. And we started with math, so what are we probably moving toward? Word, okay? What's it mean for them to be complementary? They add up to 90. Do they add up to 90? So what do we know about angle 1 and angle 3? They are complementary. So we can write that angle 1 and angle 3 are complementary. Okay? Ooh, we have an even bigger hint on number 7. What's our even bigger hint on number 7? Given. We have one more given we have to use, right? So that's where we're going to put angle 2 and 3 are complementary.
No.
Okay? So now, this is when we talked about it a couple times earlier. We haven't used it yet. We talked about it a couple times earlier during that name that proof, name that theorem one. We went from angle 1 and angle 3 are both complementary, angle 2 and angle 3 are both complementary, and now we have congruent angles. Two sets of complements, now we have congruent angles. Anyone want to take a shot at that one? Two sets of complements, now we have congruent angles. Maybe look back at your angle proofs reference. Two sets of complements, now we have a set of congruent. Congruent complements theorem. It even follows through, okay? Complements and congruent. So it's congruent complements theorem. And what that says is that's just saying, hey, if we have two angles complementary to the same angle, angle 1, angle 2, both complementary, angle 3, it has to be congruent. We practiced that earlier.
36 pages of notes later and we're done.
We
Okay?
didn't go through all 30 words.
Correct. Okay? Questions on that, guys?
It was close enough.
Okay. Now I know this is still new to us. But I feel like we're getting more comfortable with it. We might not be like perfectly comfortable, like you're like okay, like sharing our personal stories comfortable, but we're getting more comfortable with it to the point where I think it's becoming a little more natural for us to think this way. Okay, and that's good. It just takes more practice. Okay, and so we're gonna have a little more practice here. And on this worksheet, guys, we don't have any of them where both sides are blank. Okay, we don't have any where the whole thing's blank like we did on the last worksheet, like number 8. Okay, on this one, there's going to be at least part of it filled in every time. Okay.
Are you?
Now, if you guys need more help, you guys can look back at your notes. Right, that angle proofs reference page, it literally says reference. So it's like it's a good reference for you. It literally says the word reference. Okay. You can also look back at our notes. Definition of perpendicular.
Page 15, right?
What's the home one? Oh, sorry.
Okay. So heads up, guys. This is due Thursday. Then we're taking our quiz on Thursday. Okay, over last section and this section. We'll then review chapter 2 for a bit. We'll review chapter 2 on Monday, and then we'll test the following Wednesday. That Wednesday, okay? Ooh, there you go. This is why I chose you, Betsy. I wouldn't go that far.
I'm just going to do this. I'm putting this in my map. I'm just going to figure out tomorrow.
I don't want to do this.
No, my dad is basically. Oh, God.
Hey, reminder: if you need additional help, what can you do, guys? Watch the video. What could you do? What could you do before, after school, or during study hall as well?
Ask you for
Yeah, come talk to me, right? Yeah, I like you guys enough to help you.
Get it. Pathetic. Unpathetic.
That was pretty bad. That's so terrible. It's more terrible than paper is.